Hi everyone. This video will demonstrate solutions to the types of problems you can expect to see on this week's quiz. Each problem type will have two problems. Watch the first problem, watch the first solution, pause the video, attempt the second problem, and then resume the video to watch the solution and compare that to yours. So these first two problems are asking us to find the slope of each line from the graph, and to do this we pick two nice points on the graph that look like they intersect at readable spots. So for number one, I am going to pick this point here and this point here, and now I'm going to draw my triangle that indicates rise and run, and I'm going to measure each of those. And the rise for this particular problem is going to be down 1, so that's -1. And the run for this particular problem is 1, 2, 3, 4, 5 to the right, so that's positive. So this is the run, and this is 5. So slope is equal to rise over run is equal to -1/5. Oops. Pause the video and give number two a try, then resume the video to see the solution. So for this problem, I'm going to pick a couple of points here, and it looks like that's a nice spot that intersects x and y in a nice place, and this is another nice spot. So I'm going to draw my triangle, and then I'm going to count off my rise from my initial point. So this is 1, 2, 3 up. So the rise for this problem is +3, and the run for this problem is +1. So m, the slope, will equal 3 divided by 1 is equal to 3. The next two problems are asking us to calculate the slope of the line through each pair of points, and importantly, we need to simplify any fractions. With these, we decide which points we're going to use. We have a point 1 and point 2, and this enables us to label the x's and y's within those points. Remember, points are always written as ordered pairs with x and y in that fashion. So that makes -11 our x1 value, and -2 our y1 value, and 9 our x2 value, and 12 our y2 value. To calculate slope, we know that that is y2 minus y1 divided by x2 minus x1. And now I'm just going to plug in values. Y2 is 12. Minus, and I drop my parentheses to take care of any potential double negatives. My y1 value is -2. My x2 value is 9, and the parentheses go again, and my x1 value is -11. So when I simplify this, m becomes 12 plus 2 is 14, and 9 plus 11 is going to be 20, but I can reduce that fraction. I can divide both top and bottom by 2, and I get 7/10. So the slope is 7/10. Pause the video, try number 4, and then resume it to check your solution. I'm going to label each of my points, P1 and P2. And now I'm going to label the ordered pairs within those points. This becomes y1, get x2, and y2. And again, we have slope m is equal to y2 minus y1 divided by x2 minus x1. And now I'm just going to plug in values. Get -15, and we drop our parentheses, and then there's a -7 in there. We have x2 is -14, and and our x1 is going to be 14. So when we simplify this, we get the double negative for the numerator becomes minus 15 plus 8, which minus 15 plus 7, which gives us minus 8. And our denominator is minus 14 minus 14. Don't think that that cancels out. That becomes minus 28. The negative divided by a negative is a positive, and I can also reduce that by dividing both top and bottom by 4. So this becomes 2/7. Problems 5 and 6 are asking us to sketch the graph of each line, and both of those equations are given in slope-intercept form. So the first thing we do is we identify our y-intercept, which is plus 2. So the y-intercept is plotted on the graph along the y-axis at that value. So I'm going to drop a point here, which is 2. The slope that's given to us for this is 2/3. So our rise is plus 2 and our run is plus 3. I'm going to go up 2/3, and this becomes our second point. I'm going to clean that up a little bit so that we don't see that stuff in there. And now I'm going to draw a straight line through those 2 points. Remember, to graph any line, all we need is 2 points. And we draw arrows on the ends of our lines to indicate that they extend to infinity. Pause the video, try number 6, and then resume the video to check your solution. So for number 6, we have a y-intercept of minus 3. So we go to the y-axis and we plot that at minus 3. We have a slope of minus 2/5. So that tells us that we're going to drop down 2, 1, 2, and then over 5, 1, 2, 3, 4, 5. There's our second point. I'm going to clean up these other hash marks that we put in there. And I'm going to draw a straight line through those 2 points. And that becomes the graph of this particular equation. Number 7 and 8 are asking us to write the slope-intercept form of the equation of each line. So remember, when we're writing these, we are writing this in the form of y is equal to mx plus b, where m and b are values that we take off of the graph. So the first thing that we can do here is find our b, because that's just where the line crosses the y-intercept, or sorry, where the line crosses the y-axis. And so for this particular case, this is going to be down here at b is equal to minus 4. Now we need to measure the slope. And we're going to try to pick another nice point on the graph where it crosses at a decent place to pick numbers from. And it looks like that is not a bad spot. So we're going to draw our triangle. And we see that our rise for this case is down. So it's going to be 1, 2, 3, 4. And that becomes, because it's downward, this is going to be minus 4. And our run for this particular case is going to be 1, 2. So our m is equal to rise over run is equal to minus 4 over 2, which reduces to minus 2. We have our b value, and now we have our m value, and we can just write that. We can drop those values into our general form if we want to rewrite that as y equals mx plus b, and then we would just replace the m and the b with those specific values. So y is equal to minus 2x minus 4. Pause the video, try number 8, and then compare your solution to the resumed video. Once again, we're looking to write an equation in the form y is equal to mx plus b, and we can pull b right off the graph because that is where the line crosses the y-axis, and we see that that occurs there. So we know that our b is equal to minus 2. We're going to pick another nice point on the line, and it looks like that goes over there. Once again, and this is to find our slope value, so I'm going to draw our triangle between those 2 points. And then we're going to count off our rise, which is plus 1. That's a change of plus 1 going up. And then our run is going to be 1, 2, 3, 4, 5. So it looks like our run is plus 5. Our slope is equal to our rise over our run, so this becomes 1/5. Now we have our slope value, our m, we have our b value, and we can just drop those into our general equation. I'll rewrite that, y equals mx plus b, and this means that y is equal to 1/5 x minus 2. The next 2 problems are asking us to write the slope-intercept form of the equation of the line through the given points. So we have a process for this where we begin, this is a 2-step process, where first we find the slope of the line using the slope formula, and then we find the y-intercept. So we start out by labeling our points. I'm going to label this as P1 and this is P2. So this allows me to label my x1 and my y1 and my x2 and my y2. I'm going to calculate my slope first. This is step 1. So this becomes y2 minus y1 divided by x2 minus x1. And now I'm just going to drop in the values. I get minus 5 minus, and I'm going to drop my parentheses. My y1 value is 2. I'm going to put that over my x2 value, minus 5, minus, and then my x1 value is 3. And when I simplify this, minus 5 minus 2 is going to be minus 7. And minus 5 minus 3 is minus 8, but those negative signs cancel, so this is equal to 7/8. Now I need to find my b, and we do that by picking one of our points. Oh, I'm a little too far there. We're going to pick one of our points and plug that into our general equation. So we will work this piece by piece. We break this down piece by piece. This is our general equation that we need to find. We've already found our slope value, which is m. So we're going to plug that in. Y is equal to 7/8 x plus b. To find our b value, we're going to take one of those 2 points and we're going to substitute them for x and y. I'm going to pick this point, and my y value becomes 2, and that's equal to 7/8 is my slope, and I'm going to put my x in parentheses, which is 3 plus b. Now I wind up with 2 is equal to 21 over 8 plus b. In order to solve this, I have to subtract 21 over 8 from both sides to get b by itself. And I get 2 minus 21/8 is equal to b. Now we have b, but we still have to simplify it. I'm going to do this up here, and b will be equal to 2 minus 21. Let's clean that up a little bit. 21 over 8. I need to find a common denominator, so b will be equal to, and remember that's the same as 2 over 1, so if I multiply the bottom by 8, I have to multiply the top by 8. This becomes 16 over 8 minus 21 over 8 is equal to minus 5/8. And now I have a b value, and I have an m value that we calculated before. So I have my general equation, y is equal to mx plus b, and I just drop those values in. Y is now equal to 7/8 x minus 5/8. Pause the video, give number 10 a try, then resume the video to check your solution. I'm just going to drop a line down to be clean there. Once again, we start this out by picking our points to work with. We find our slope first, and then we find our y-intercept. So I am going to label this P1 and this P2, which allows me to label my x values and my y values within each point. I calculate my slope out first. M is equal to y2 minus y1 divided by x2 minus x1. And now I'm just going to plug in some values. My y2 is 4 minus 3. And my x2 value is 0 minus 2. I have a couple of double negatives there. So 4 plus 3 will be equal to 7. Divided by 0 plus 2 is equal to 2. So m is equal to 7/2. Now I need to find my b value. So I use the same process. I start out with y is equal to mx plus b. I replace my slope with the value that we found, and this becomes y is equal to 7/2 x plus b. Now I need to take one of my points and plug it in. And I've been given something special here. I've got a 0 for an x, and anytime we see a 0, we want to use that because it simplifies the whole process. So I'm going to plug 4 in for my y, 7/2 times 0 plus b. But 0 times anything is 0, so this goes away, and I'm left with b is equal to 4. I have my slope value, my m, I have my b value, and that's all I need to complete the equation of the line. I rewrite my general formula, and now I just drop those two values in. Y is equal to 7/2 x plus 4. (11) and 12 are a special case of the two problems that we just completed. Before, we had to calculate slope and then calculate y-intercept. But in these two particular problems, the slope is already given to us. So the first part is already done for us. We're given our m value, and then we're given a point that goes through it. So we go through the same process as before, but now we can just start out by saying m is equal to minus 1/5. And now we have to solve for a b value. So I write my general equation, y is equal to mx plus b. I substitute my slope value in there. Y is equal to minus 1/5 x plus b. I'm only given 1 point, so I don't have much of a choice. I have to, the 4 is my y value, and the minus 5 is my x value. So I plug those two values in. 4 is equal to minus 1/5 times minus 5. That's our x value plus b. We can simplify things here a little bit. The 5's cancel, and the negative sign doesn't get canceled here. So this is like my multiplying minus 1 by minus 1. and that turns out to be positive 1. But that means that we get 4 is equal to 1 plus b. In order to find b, I subtract 1 from both sides. And I get 3 is equal to b. Now I have my slope value that we calculated from before, or that was given to us. I have my b value. I can write my general equation. Y is equal to mx plus b. And now I just drop those two values right in. Y is equal to minus 1/5 x plus 3. Give number 12 a try. Pause the video. Then resume the video to check your solution. So once again, for this one, we're already given a slope value, so we're just going to drop that right down here. Our slope is 4, m is equal to 4. Now we have to go through the process of finding b. So y is equal to mx plus b. I'm going to substitute my slope value in there. 4x plus b. Now to get b by itself, I need to use more data that we have, but we only have one point that's given to us. So I'm going to plug those values in, and I get 1 is equal to 4 times 1 plus b, but this is just 1 is equal to 4 plus b. To get b by itself, I subtract 4 from both sides. And I get minus 3 is equal to b. So we have our slope, our m value. We have b that's given to us. I'm going to write my general form for the line, and I'm just going to substitute those values in there. Y is equal to 4x plus, and that would be plus minus 3, but we can continue to write that as y is equal to 4x minus 3. (13) and 14, they are asking us to rewrite each equation in slope-intercept form by solving the equation for y and then sketching the graph of each line. So we were given let's work with 13 first here. Remember, the slope-intercept form is y is equal to y is equal to mx plus b. And the difference here is just that we get y by itself. So let me rewrite this equation down here a little bit. Here. So we have 2x minus 5y is equal to 15. When we do this, in fact, maybe I should write that a little cleaner. All we're doing is solving for y. So I'm going to work with this down here, and if we're going to solve for y, we need to get y by itself. So what we're going to do is move things around, and the first thing I'm going to do is move my x's to the other side of the equation. So I'm going to subtract 2x from both sides, and I'm left with, the x's disappear, and I'm left with minus 5y is equal to 15 minus 2x, but I've still got something modifying my y. This is multiplied by minus 5, so I need to divide both sides by minus 5, and that means dividing everything by minus 5. I can break that up into two different fractions, and I can rewrite this down here as y is equal to 15 divided by minus 5 minus 2x divided by minus 5. We can reduce this. 15 divided by minus 5 is going to be minus 3. And now we have minus 2/5 x. So the double negatives here cancel, and what we're left with is y is equal to minus 3 plus 2/5 x, and I'm going to write this up here. In fact, I'm going to change the form so that the x comes first. I'm just changing the order on the right side, and y is equal to 2/5 x minus 3. I'm going to slide up a little bit so that I can graph this. And to do that, I have my y-intercept. This is minus 3, so I am just going to drop that on the graph. Minus 3, put that right on the y-axis. And my slope is going to be 2/5. So I'm going to go up 2, 1, 2, and over 5, 1, 2, 3, 4, 5. And I've got my second point right there. I'll clean up these other hash marks that are in there. And I'm just going to draw a straight line through those 2 points. Hopefully that comes out sort of straightish. And I put an arrow on each end, and that's the solution to this particular graph. Pause the video, try number 14, and then resume the video to look at the solution. I'm going to rewrite this particular solution down the bottom here so that we can calculate out I'm going to rewrite the original equation out. 3x plus 2y is equal to 6. I'm going to slide down a bit to go through all the algebra. I'm going to start out by bringing my x to the other side. Remember, I'm trying to get y by itself. So, and everything else on the other side of the equation. So I'm going to subtract 3x from both sides here. And I'm left with 2y is equal to 6 minus 3x. I've still got this 2 modifying my y, so I have to divide both sides by 2. Everything needs to be divided by that. And I'm going to rewrite this down here, and I'm going to split that right side up into 2 fractions. Y will equal to 6 divided by 2 minus 3 divided by 2x. And I can simplify that. 6 divided by 2 is 3. Y is equal to 3 minus 3/2 x. And I'm just going to rewrite this so that my x term comes first. Minus 3/2 x plus 3. I'm going to rewrite this up here so that I can see it while I'm graphing it. Y is equal to minus 3/2 x plus 3. Slide up a bit. In order to graph this, I need to find my y-intercept, but my y-intercept is given to me here. This is plus 3. I'm going to put that on my graph. That occurs at y is equal to 3. And my slope is minus 3/2, which means I'm going to go down 3 and over 2. And when I do that, I go down 1, 1, 2, 3, over 2. And my second point is here. And I'll clean up these other points. Now I'm going to draw a straight line through those 2 points. And I put arrows on the end of my lines. And that particular problem is done. As a little bit of a review, we've got some absolute value problems here, and you can expect to see these on the test also. So let's go through this, and we'll recall that when we deal with absolute value problems, that we have to understand absolute value means that whatever is inside those absolute value bars can be either the negative or the positive version of the value on the right side of the equation. So this tells me that whatever is inside of here can be equal to minus 57 or plus 57. And so I have 2 equations that I have to solve, and I have 2 solutions at the end of this. So what I do is I take whatever is inside of my absolute value bars, and I write my first equation, which is going to be 6 plus 7n is equal to minus 57. And then I'm just going to write my second equation before I do anything. And I'm going to have 6 plus 7n is equal to plus 57. Now I just solved these for n using my equation solving techniques. I'm going to subtract 6 from both sides. And when I do that, I get 7n is equal to minus 63. I divide both sides by 7, and n is equal to minus 9 for this first equation. Now I have to solve my second equation, and I'm going to do the same thing. But now, when I subtract 6 from both sides, I get a different value on the right, and I get 7n is equal to 51. And I'm going to divide both sides by 7. And I get n is equal to 51 sevenths. And that can't be reduced any further. That's as far as that goes. So my solution set to this problem is going to be minus 9 and 51 over 7. Give 16 a try using that same process. Pause the video while you do that. Then resume the video to check your solution. So for problem 16, we know that whatever is inside of this has to be equal to minus 14 or plus 14. So I'm going to take whatever is inside of my absolute value bars, and I'm going to rewrite the equation so that that is equal to both of those with two equations. 6x minus 4 is equal to minus 14. And before I actually solve anything, I'm going to write the other side, which is going to be 6x minus 4 is equal to plus 14. I'm going to solve the left side, equation number 1, by using my standard equation solving techniques. I'm going to add 4 to both sides, and I get 6x is equal to minus 10. I still have to get x by itself, so I divide both sides by 6, and I get x is equal to minus 10 over 6, but I can reduce that by dividing top and bottom by 2, and this gives me minus 5 over 2. I'm going to solve my second equation now the same way. I'm going to add both sides, 4 to both sides, and I get 6x is equal to 18. I'm going to divide both sides by 6, and I get x is equal to 3. So my solution set for this particular problem is going to be minus 5 halves and 3. Oop. And that's it for these problems. The answers are at the bottom, as usual. You can check your solutions as you go. Thanks for watching.